In today's session we are going to look at a simple problem of isometric. The problem is there in front of you. We have been given these two views of the object, and we are supposed to develop the 3D of this particular object. Now, though the front view and top view are mentioned in this, front view and side view are mentioned in this, we did not bother about which is the front view and which is the side view in this case, because the origin status lies at the extreme bottom corners. That is how we will proceed. So let us consider this problem without dimensions as of now. So if you can see, this thing becomes my origin and this thing also is my origin. Let me call it O dash and let me call it O double dash, or you can take it vice versa also. So now we know that this particular, the lengthier side is on the right side of O dash and the smaller side is on the left side of the O dash. So with respect to this, when I try to make the 3D object of this, so as you can see, I have tried to draw the master box for this diagram. Now since we have not considered any dimensions, I have taken these sides relatively. See this, so we can see that this lengthier thing is on right side of the origin. Let me write this as origin. This thing becomes my origin, of course. So on the right side the linear dimension is there. So on the left side the smaller dimension is there. You can see on the left of this O we can see that dimension. Fine. And the height is common for all the dimensions. So let us begin with it. If you see this object, to get this view, now for understanding, let us say this is left hand side view, LSV, and this will become front view in that case. So in order to get LSV, we have to look from this side of the front view, and to get front view we have to look from this side of LHV. This is how I will club the arrow so that it will be clear to all of us. Fine. So now when you are looking from this side, it is very much evident that at the end there is going to be a surface, a complete straight surface, whose shape is in this manner, somewhat in this manner, in the left hand side view. So when you are looking from left, let me say this will give me LSV, and let me say this will give me front view. I hope it is clear by this time, because this linear dimension is in front view. Since we can see this length here, from this side we can see, that's why I have named it front view, and this will be LHV. So when you are looking from this side at the extreme end, so when you are looking from this side at the extreme end, we'll be able to see a flat surface. Now the shape of flat surface is somewhat like this. So there is a flat surface and then it is tilting down. Now this particular thing or this region, let us divide. So as you can see, I have tried to divide this different layers, so that this particular A layer and this A layer, they are the same. So in short, the length of layer A will be obtained from this view. However, the width will be obtained from this view, and the heights are same. That is how it goes. So layer A, which is of this shape, which will be seen from left hand side view, will be having this much thickness or width. That is what we can see. So let us begin with it. So right from the center, certain length it will go on either sides. So when I start with it, I'll get things like this. Now of course, now this line is a plane, this line also is a plane. When two planes are at the same height, they actually form a rectangular plane like this. Now for front view, means in this direction we will get a rectangular surface which is vertical, but if you see its projection, it appears to be inclined one. So there is an inclined plane on either side, present on either side. So let us try to draw it here. Now we are proceeding without any dimensions, only conceptualization is what we are doing. If you see, this width and this width is same. A similar structure will appear on that side. and it is evident that this thing and this thing, they lie on the same height, so that height should be parallel with it. So if we consider that thing, this will be modified to this kind of inclined line. We may or may not see the line which is present and starting from this end. So let us complete it. Now thereafter you can see section B. Now section B you can see is divided into two parts here. This is a prominent part and this one also is a part. Now if we go by that logic, we can see that the same thickness is continued which the A is having, or same length that A is having is continued down. So if by projection it is definitely this side of the view. Now there is a differentiation between this view and this view also, or this area. Let me highlight it so that we will understand. We can see that there is a cutting edge, or there is a bifurcating line present. That means the depth of this particular shape and this particular rectangular shape are different, of which if you see this shape is continued, this rectangular shape is continued down in this form. So we can say this is the nearest one to the observer as far as the front view is concerned. So for front view, this part is nearest. So for front view, this part going down is the nearest one, and hence this remaining part is this part which is away from the observer. So that is how it will be proceeded. So there is certain distance, it is carried outside and then it is tilted. However, on this side it is straight coming down. You can see it is straight vertical line. It is coming down up to the bottom because there is no bifurcating line present between this part, between C and between D, and hence we will continue it like this up to the bottom. From bottom it is continued or up to certain distance. You can see there is a bifurcating line. So let me say that up to certain distance this thing is continued, and the same is present here, but this line we will draw afterwards. We can see it is coming down from here up to certain distance, and then it is coming out like this. You can see this particular part is this one, and then you can see they are continued to get clubbed. So there is an inclined line. So basically there is an inclined line which will club these two. This is how the outer shape is given. Now let us consider this section of B. It says that this particular part is this thing. You can see this thing has a closing boundary which is inclined, which means this surface is an inclined surface, which is the same meaning. I'll repeat this. We can see the section between B and C. They have a common line between B and C, which is inclined one. So if we project it on the side view, we can see the distance between this point and between this point is this, which means this particular shape which we are able to see is an inclined plane which we are supposed to draw. So this shape, you can see it's a line, so basically it represents a plane. This line has a height, this one, so it is coming out by certain distance. If you are confused about this line, you can definitely say that that is the change of plane line between this inclined plane and this vertical plane which we already have drawn. So in the same line of this particular line, we will have another surface emerging like this, which is this one. Then it is coming outside slightly, so it will come out slightly and it will form a rectangle. And why it is forming a rectangle? We can see two planes which are at the same height. So this plane and this plane are the same, and that's why they form a rectangle. Then you can see that rectangle is continued as an inclined line, but that inclined line is also part of this particular line which we already have drawn, this one. And then this particular line has gone inside. You can see we have already drawn this line which is this. So from this point it is gone in parallel to the width. So inside parallel to the width, this line will be passed up to certain distance as per the dimensions, to which this line will come and merge. Now we can see this inclined line and this line are forming a same line in the front view. So naturally there is a line which is coming down, you can see, and there is another line which is coming out. So since they are straight lines, this thing I can say is a vertical plane and this thing I can say is a horizontal plane. So from here it will come down as a vertical line. This thing will go and meet it, and ultimately this thing will meet it. Let me draw it precisely. So that they will be clubbed like this. Now this line and this line of course is parallel. Now if we can see, this is a continuous plane and hence it will be continued in the same manner. We can see that they are continued up to this point, which we already have drawn like this, and where they are concluded, you can see up to this point, there we can see a straight line, which means these two lines are connected thereafter. Down there we can see a rectangle. Now there is a possibility that this particular rectangle and this rectangle are same, so it is just a possibility which I want to discuss, that it will look like a rectangle like this. It is just a discussion, it's not the final answer about the lower part. This is how we will obtain the shape. Now if you can see, the left hand side view is satisfied with the given view, but the right side view is not front view is not satisfied. You can see a line there. Since these two are the same planes, ideally with this given view, this line should not exist, because it's a straight same plane. But since there is a line given, we have to draw that line, and which means something else. So that something else is like this. Let me draw it and show you. Instead of showing it like this, this is what I would like to show. So that not only the front view I can see, not only in the left hand side view I can see a rectangle, but also in front view from this side we can see this edge and this edge. So there is a small rectangle that can be seen between this edge and this edge, this edge and this edge. That is how my problem gets completed. So I think it is clear to you how to solve the problem and what are the views which are given. Fine. So let us draw it in the manual way. I am going to use a CAD tool for drawing. However, students are instructed and advised to draw using the manual drawing. So first of all, I will figure out the basic dimensions. We can see the width in this case, the maximum width in this case is 50. The maximum length in this case is 20 plus 40 plus 10 plus 10, which gives me 80, and maximum height we can say it's 20 plus 40 plus 10, which is 70. So I have this solid is of length 80, of width 50, and of height 70. So let me quickly make the master box for it. the height of 70. You can see definitely on the left side of origin will lie somewhere here. On its left side it is 50 lying, so on this side I will take 50 dimension. I will come down by 70 again, and again in this direction 50. Now I will go in this direction where the dimension would be 80, the height would be 70, and again 80. Then from here also 80, and in this direction it is again 50. So that is how my master box gets completed. Now on this master box, whatever I have drawn here, I am going to follow. The shape would be like this, and dimensions I will pick up from this file. The very first thing we had started with, you can see this particular thing we have drawn. If you go through the diagram, it is of the width 25 and of length 10, we can see. So let us begin with it. So from the center point, I'll go on either side by 12.5. So this thing becomes of 25. Then I will come parallel to the length at 10, again 25 in this direction, and again 10 here. So this is the first flat surface I have obtained. However, the next horizontal line which we can see, it is at a depth of 20. So I will draw a line parallel to this at a depth of 20. Rather, I will copy a line similar to this. I will make an offset line to this one at a distance of 20. You can see that. And from that we can see at a height of the depth of 20 there is another line which is horizontal and which is of 10. So I will draw a line from here of width 10. I know that these lines are connected in this manner, which forms one side of the slant surface. But we can see the slant surfaces are present at both the ends, and both are at a depth of 20. So for that I will draw a line starting from this point, and which will be the parallel with this particular line, which is of 50 length. We know that the total width is 50, so I will draw this line only of 250. I know that at the end of line of 50 this line is connected, so I will simply join this point with this. If at all we try to draw a line similar to this, we can see it is going inside. So let me give a try. For your understanding, I am copying this line which should emerge like this. We can see it is going inside this solid, and that's why it will not be visible. And as per the syntax, we don't show any hidden line in the isometric. So that is it about the upper part. Now what we can see, it is coming out at the same level where this is ending. It is coming out by a distance of 10, and then it is spreaded at a width of 20. So let me do the same thing. It will come out by 10 and it will be spreaded across width of 20. Again it will come inside by 10. Now we can say from thereafter there is an inclined line which comes up to this portion. So in short, we need to connect them, and before we connect them we can see it is coming down and then it is coming outside. So I will draw that line also. We can see it is coming down by a depth of again 20, and hence it will come down by 20 like this, and then it will emerge parallel to the length. Now it's a random line that I am drawing, to which the extra part I will delete afterwards. So it's a random distance to which I am drawing this line. At the same time we can see there is a line coming down and is continued up to this point. So we can see the length of this point is 10 plus 10 plus 40, so it is 60 is the length. So of course we can see it here also coming down, and then length of 60. So I will come down completely and then in this direction by 60. Now as it arrives at a distance of 60, it is going up again by a height of 10, and to which this line is connected. So we will draw a line going up by 10, and that line will cover this end. Now thereafter we can see this particular same line in our solution. The same line is continued till the next end, which is connected with this particular end which we have already drawn. So we will draw a line starting from this point. The maximum width is 50 again, and now this particular line, this particular point rather, will be connected with this point. Now we know that this line and this line are parallel with each other. So in short, I need to draw line parallel with this from this point and somewhere at this distance. Now from here the total distance covered in this manner will be 50. So I will draw a line at a distance of 50 from this line. Now we can see it is intersecting with this line. So what I am going to do is I am going to show only this part and this lower part. You can see it is passing through the same point, right? And from there the extra part I will keep as it is because I want to show it as a construction line. So let me quickly do it for you. So this is how I have shown the extended part as the construction line. Now we know that there is a line emerging meeting this surface and then they are passing like this. So let me quickly draw it. So this surface against this one, it has to pass in this manner such that this and this point will meet. So that is how the part is constructed. So the extra lines which we have drawn will retain because those belong to the construction line. So let me quickly apply the changes, and of course I will draw these lines at the dark one. So that is how I applied the properties to construction lines and the main line. Now the last part, which is like this triangular shape, we know it. So we'll continue this end or this line from this point up to the endmost line on this particular line, and then from this point we will connect it, and from the bottommost point we will connect this, and then we have to draw a line in between them. Starting from this point up to the next. So that is how the total line is completed. Let me apply the properties so as to make that thick. So as you can see, that is how it is completed, which satisfies not only the front view but also the left side view. The last thing which I want to discuss about is this particular line. If you can see it properly, the line does not exist in this portion, but it does exist here, and hence only this part of the line will be made dark. So we will make it, and rest of the part we will add all the constructions. Students, if you have seen it properly, I have not deleted any of the construction line which is supposed to be retained. So with that, at the end I will add the angles in the bottom, and that completes our problem. We did not give the dimensions in the isometric as of now. So as you can see, the problem is completed. Thank you so much for watching the video. If you have liked this, please subscribe for the further videos so that your understanding will be much better. Thank you once again.